Question that should get your group to a 5. We said our next test is on Wednesday, but really we would like to start it on Tuesday. No, other way around, maybe. Okay, so yesterday we talked about how to graph what kind of functions. You got your notes. You were supposed to be working on things. 1. What kind of functions? Yes, 4, you can have your point. Square root functions. If I were to hold up a body part for square root functions, keep it clean. What would I hold up? I would hold up my arm. I think I gave a terrible Hitler reference yesterday. That's terrible. Because it doesn't actually grow that quickly. It's actually more of like a lazy man high five. It's like literally a lazy man high five. If there is a negative in front, what happens? If there is a negative in front, what happens? It does flip the arm, so now we're doing a low 5. So we did one like that yesterday, number 4, and I asked you to work these 4, and thankfully there are graphs on the back of your notes for you to do them on. Most people haven't showed me that. That's one thing you want to get done today when I get done rambling. However, we do want to change one problem. Now, table 4 has already shown me they finished their work, so they don't have to change it. But otherwise, let's change problem 7. Let's get rid of that 3. Cross out the 3 on number 7. If you don't show me this today, and you don't show me this Monday, I'm not going to change to 0. Again, Miss Compton's running out of time in life. You got to get with it. It's only 4 problems. Surely, to goodness, between 3 days of class time, you can find a way to do 4 graphs. Now, one problem with these graphs is you need what kind of device in order to do them? Yes, every group can have a point. You need a graphing calculator, and I'm trying to pack up and move, as are the rest of us in life. So if you need a graphing calculator, and then the bottom thing, make sure you put it back in there for me so I don't have to track them down. I would really appreciate it. So I don't mind if you use one to do these 4. Make sure you put it back in the tub for me. Yes, I did. I just knew y'all had one. I was like, I better put my hands on it before we move. Yes. Okay. Today we are doing one new section, and then that's it. So if Seth's been actually paying attention, we've added, subtracted, multiplied, and divided. That was easy. Function composition, not so easy. Inverse is easy until we did function composition with inverses. Function composition, we use 2 different acronyms. What are our 2 acronyms? Yes, and you can have a point for that, ma'am. So we did function composition, and then yesterday we graphed square root functions. And then last but not least for this next test is something called nth roots. Now, nth roots can get really complicated. We're going to try to keep it simple for us. But, of course, if you're going on a pre-cal, they'll add a little bit to this after we get done. There's always more you can do. And that's why we're going to wait a second on the math workshops, because the math workshops also involve nth roots. Okay, so it's been a while, and we kind of talked about this yesterday, and maybe you don't remember your teacher saying these words, and if you have to absolutely know them, I would probably say yes, because sadly enough, I've seen ACT questions that use the word index. So the tiny number they write out front is called the index. You already know what a radical is, so you're not surprised with the radical side. The number underneath is called the radicand. Now, I understand if you don't memorize radical side and radicand, but seriously, I've seen the word index on the ACT before, and they expect you to know that it means a little tiny number on the house. Day. I can't talk this loud. Can you shut it? Never mind, Bristol got it. The cool thing in the new school is that I have like a little speaker thing so we can be super creepy and everyone can hear me for no good reason. Okay, so the little speaker thing, Miss Hester, where it's like I'm Darth Vader and I'm going to echo everywhere.
Well, they should have put a soundproof door or soundproof doorway.
They have speakers in the room and they gave me, it's like this little thing and you wear it around your neck and like, I don't know, when I start talking, like all of a sudden you can hear it everywhere. It's creepy.
I think it's just like
it is weird.
Oh
yeah, I've already tried it out. And I assume we're going to hover cam it on Monday, but eventually I'm going to smart screen smart enough. Okay. But I kind of forgot what we learned at training. I'm kind of as bad as them. I was like, What button did they say I was supposed to press again? Because we didn't actually do it ourselves, so I don't remember. I don't know. I know. So bad. Okay, so let's just keep it simple for the moment. Let's look at, they have some examples at the bottom. We talked about yesterday, if they don't write a number, what's understood to be the index? Yes, 3 gets the point. 1, you're on my nerves. Okay, so A and B and D all have an understood 2. If you want to write it, you can. It's understood to be there. The way there's an understood 1 in front of that X. No, it's really hard to read, but you're pretty smart because of the 243. What do you think the tiny number is here? It is. It's a 3. Now that is one problem with my super old notes that are handed down to me, is that they're kind of hard to read. So if you have a question on these or on the next test about, hey, what is that tiny number? Totally understand. Okay, we have talked about imaginary numbers in the past. Today we only want to deal with real numbers. So if you're looking at A, B, C, and D, there's already one problem we're going to get rid of. What problem are we going to say, no, we're not working it today? No real roots. Are we going to get rid of this problem? 1, lose a point. Are we going to get rid of C? Are we going to get rid of B? Are we going to get rid of D? Which problem are we going to say we're not doing today? Why D? Why? Exactly, because that negative under the house, negative under the radical. Notice that. Therefore, there's no real roots. We would have to live in imaginary land, and we're not going there today. Now, when we were working our bell ringers yesterday, let me remind you of some of the bell ringers from yesterday. For instance, x to the 4th, you then said an x squared came out. Why is that? Because there's what? Yes, and that's still going to work today. So if you want to write out, so let's start with, for instance, this one, y to the 4th. If you want to write out 4 y's and then circle, I have these 2 pairs, I have these 2 pairs, and that's why y squared came out. You can. No one said you can't. And heck, 16, you could kind of do the same thing, because isn't 2 times 2 times 2 times 2 16? So if you broke 16 down to its prime factors, which would be all 2's, you could say, hey, I have a pair of 2's, they come out. I have a pair of 2's, they come out. And then 2 times 2 is 4, so no wonder they have a 4 there. So if you like this circle logic, it will work. But let's face it, on C, Hunter does not want to write out B 25 times. So this circle logic can work, and you can always use it, but no one wants to do it when the exponent gets super high. So instead, what we think about is that really, if we're taking the square root of something, it's the same thing as raising it to the 1/2 power, or at least that's how I think of it. So this sounds strange. Maybe Miss Brister wants me to explain it a different way. She'll interject when she wants to. I think of it as 16 raised to the 1/2 power. So the square root of 16, I think of it as 16 to the 1/2 power. So what squared got me 16? 4. And I kind of think about the same thing with that y to the 4th. I'm like, y to the 4th to the 1/2 power. And it works out better with my exponents like that, because I'm like 4 divided by 2, because 4 times 1/2 is 4 divided by 2. And that's how I ended up with y squared. Now, again, that's how I think about it. If you want to think about it the way I do, you want to do the circle pairs, either one's fine. Square roots are easy because you memorized your perfect squares. I know the square root of 16 is 4. So we like it when there's a 2 outside because you already memorized all those. Now, why do you think the final answer has a plus or minus? Why do we need to add that in? It's really very literal today. Didn't it start off with a plus or minus?
Yes.
So we're going to keep it. Yes, dear.
So like in C where it says B was like the, can't you just like what I did like round them like the nearest even number?
Yes, but instead of with 2, since the index is 3, we're going to go with what's the next thing that's divisible by 3. So, like, 24. You got to go down. So, 24. And 24 divided by 3 is 8. That's why it ain't, like... Okay, cool. Yes. Yes. Okay, so we're okay with A. Let's go to B. Now, B is super annoying because it's... I got to write it to the side. It's negative square root of x squared minus 6 to the 8. But again, I think of it as... I'm going to leave that negative on the outside. I think of it as, instead of a square root, I think of it as being raised to the 1/2 power. So I think of it as... I'm going to put a lot of parentheses today. I think of it as this, all raised to the 1/2 power. 1 lose another point. So if I'm doing 8 to the 1/2 power, that's 8 divided by 2, which is 4. So no wonder they got x squared minus 6 raised to the 4. So again, in my mind, a square root is the same thing as raising something to the 1/2 power. So we'll skip C for a second. Let's go down to Guided Practice 1A towards the bottom. So I know I'm going to keep the plus or minus. I know what the square root of 36 is. It's 6. And I know it's x to the what power? But again, if you're still slow on these, you could always say it's 36x to the 10th raised to the 1/2 power. So square root of 36, which is 6, 10 divided by 2, oh, that's why it's 5. Or, again, worst comes to worst, you can still do Hunter's logic of writing out all the x's, circling up your pairs, and figuring out how many pairs get to escape. At least he's going to reach an answer. It's better than the blank papers I'm going to see. Okay, 1b, I'm going to leave that negative sign on the outside. I'm still going to have y plus 7, but what power is it going to be raised to? Well, it was raised to the 16th, but I'm taking the square root. So it's going to be, yes, so it's half, so it's 8, yes. Again, I'm thinking of it as y plus 7 raised to the 16. And I think of square root as the same 16. I think of it as being raised to the 1/2 power. 16 divided by 2 is 8. But again, Arturo's logic of just taking half is going to work. And so when we get to C, which has a 3 as the index, instead of raising it to the 1/2, I'm raising it to the 1/3, or I'm dividing everything by 3 in the exponents. Okay, so let's be brave and go to C, which has a different index. It has a 3. When you're super on my nerves. I don't know why, you just are. Okay, so on C, we have 243. But I would have sworn at the end of the last semester, you took a perfect cubes test. So you're supposed to know what cubed is 240. I mean, what to the third is 243. There's a reason we made you do these things, so life would be faster. So what to the third power is 243? And Miss Compton can't read, because that's not supposed to be a 3. That's supposed to be a 5. Darn it. Yes, because it says the 5th root. Darn you, tiny numbers. So change your 3's to 5's, and let's change our whole focus. It's something to the 5th 243. And no, I wouldn't expect you to know that on your own, except, of course, we do have the answers on the paper. So apparently 3 to the 5th is 243. Again, Miss Compton's cheating. In real life, I would probably have to sit on my calculator and guess. But we're using mostly low numbers in here, nothing above a 10. So is it 2 to the 5th? Is it 3 to the 5th? 4 to the 5th? 5 to the 5th? And it ends up being 3 to the 5th. Okay, so again, that's how they got the 3. Now, as for the others, since it's a 5th root, I'm thinking of 20 divided by 5, that's how they got a 4. 25 divided by 5, that's how they got a 5. Now, again, if Hunter wants to write out A 20 times, he can, But we're not looking for circle buddies anymore. We're looking for, since our index is 5, there have to be 5 of them together. So when I get 5 of them, that one gets to come out. And clearly, since it happens 20 times, that's why we're going to end up having 4 of them come out. So if you want to use Hunter's circling logic, it will work, but it's going to take some time. Again, what I think of is I raise the entire thing to the 1/5 power. Because I think of something to the 5th, like the 5th root is the same thing as raising it to the 1/5 power. And if I typed in my calculator 243 raised to the 1/5, it would tell me 3. 20 divided by 5 is still going to be 4. 25 divided by 5 is still going to be 5. So I'm still getting the same answer as them as well. So either you're smart like Arturo, you have to think it through using exponents like me, or you're thinking like Hunter does with the circle buddies, but again, the circle is not buddies anymore. It's got to be whatever the index is. So if the index is 5, there have to be 5 of them. If the index is 3, we would have to circle 3 at a time. Okay, let's go on to the next page. And in fact, we'll probably let the Bollinger go until Monday, because I just too many problems in one day. Okay, I love you dearly. I'm not even going to bother with 7, 8, 9, and 10, because everybody in the room knows how to put things in their calculator. I say that, and that's a lie. I need to show you how to do 9. Arturo, bring me a calculator. I think it's to the 3rd. I can't tell, Miss Brister. This is terrible. Thank you. Okay, every group can have 2 points except one. I don't know what y'all are doing, but I know you're distracting me. I know you're straight up distracting me. Yes, dear. 9 is to the 5th. Thank you. Okay, so I'm going to show you how to type in number 10. Everybody in the room knows how to do 7 and 8 already. Everybody already knows where second square root is. Arturo knows second square root and at 58. And then it says 3 decimal places, so 7.61616. So if Arturo can't do 7 or 8, I don't know how to help him. He already knew that before he even met me. However, Arturo doesn't know how to type in a 5th or a 4th or anything besides as square roots into his calculator. So again, I think of a 4th root as 71 raised to the 1/4. So what I would do is literally type in 71 and raise it to the 1/4. Now Arturo has a fancy calculator. And while that's lovely, the rest of us are not that fancy.
Sorry.
You're allowed. So Miss Brister's going to hand me her non-fancy one. You're fancy too? Oh, darn it.
Just got the other calculator.
I can do it on my phone. Most calculators aren't this fancy. Come on, phone. Oh, I know, because I lock you. In fact, your phone is actually fancy, because look, your phone has it where you can do a second, a third, and you can tell it. But I'd rather just do 71 raised to, where's my exponent?
There.
Raised to, and then I'm going to put it in parentheses, 1 divided by 4. So you might have to put the 1/4 in parentheses, was my whole point in showing you that, is if you're trying to type this in, you might have to put the 1/4 in parentheses just because your calculator might not be fancy. Okay, so far today, the first part should have not been overwhelming. Definitely the last part's easy. Now for this middle part that I've skipped. Goodness gracious. They're getting real picky, Miss Brister. The notes above. The identifying the principal root.
I know from before there's a 4 over the square root. Number 4 here.
Yeah. Well, like I know this one's 6 y to the third. It's just that they're wanting me to say it's abs-val of that. So they're wanting me to say 6 abs-val of y to the third. Do I go into that or I let it go? And you want to know why the other groups got points and you didn't, please. Okay, we're going to work these the way we just worked the last ones. For those of you who are true math nerds, here are the words that were on this paper that we're going to ignore for now because Lord knows we can only do so many things in one day. If when you end up simplifying everything, you end up having an odd exponent, you want to put whatever has the odd exponent in absolute value bars, literally because we understand our answer was positive under the radical to begin with, and there's potential, like if we plug in a -2, we would have -8, and we would end up with a negative thing under the radical, which clearly we did not start off with. So their only words to the wise are if you end up having an odd exponent as your answer, put the term that has the odd exponent in absolute value bars. Am I going to count off on the test if you don't do that? No. In fact, I'm probably not going to do it here on out, even though I ought to. I ought to. Okay. If you missed 2A, I don't know what's going on with your life. Can someone tell me what the answer is to number 1 down here? Preferably not Hunter or Archer. Number 1. Say what now? 10 what? Y to the Y. It's an 8. It's an 8. Yes. Thank you, Day. 1 and 3 get a point. Let's go ahead and do number 3. What's the final answer with number 3? Raised to the what power? That's an 8 again. Yes, because 8 divided by 2 is 4. And then what are we going to put on number 5? Why? Yeah, it has a negative on the radical. I heard 3 say it. I think I heard someone else say it too. I know I can give 3 a point. Anyone else wanting a point for that? No. It was a girl voice. Okay, number 2. What's the answer to it? It's a 12. V. Okay, and then why am I going to hesitate on 4 and 6? Yeah, and the reason I'm hesitating is what was Richard saying. What are these little radicands? They're the index, sorry. What are the little indexes? They're hard to read. Okay, so we have these 3 problems left, a 4, 4, and a 6. I'll do this one, but someone else is going to handle the 4 and the 6. So again, I'm thinking through in my head, 16 is what to the 4th power? Like something raised to the 4th power gave me 16. That's how I think it through in my head. Or again, if I'm stuck, I always think through the whole thing. So 16, x minus 3 to the 12, raised to the 1/4 power. Whatever that index is, I'm raising to the 1 over that. But I know 2 to the 4th is 16 because sadly, eventually you learn 2 to the 4th is 16 and 2 to the 5th is 32 and it never leaves. So I know 16 and 1/4 would also give me 2 if I type that in my calculator. So I know a 2's coming out. Now I've got this x minus 3 and it used to be raised to the 12th power. Well, I know 12 divided by 4 is 3, but I could also do 12 times 1/4 and I would still get 3. And again, if Hunter actually wants to do his whole circle buddies, he can. But if he does x minus 3, x minus 3, x minus 3, 12 different times, and he can circle the 4s, like, because it says a 4, so he would have to do all the 4s together. Okay, I need help with number 4. Does he not know if there's some in his top drawer of his towel?
8.
It's 2 and then what? G to the, that's a 16 and that's a 24. I assume H because GH would make sense. So it's supposed to be 16, G to the 16, H to the 24 with a 4th. So I get it's 2, and then it's G to some number and H to some number. Literally divide the numbers by 4. What are my answers? So 4 and 6, because 16 divided by 4 is 4, 24 divided by 4 is 6. That's just going to be the easiest way to think about it. It is. And whatever else I've said, I've made it too complicated. That's going to be the easiest way for you to think about it today. Okay, the last problem has a 6 on the outside, a 64 underneath, and then 2y plus 1 raised to the 18th. Okay, so I'm going to do something to the 6th power gave me 64. I'm not answering any questions next. I'm out. Okay. 2 and then what? Two y plus 1 raised to the what power? Yeah, because 18 divided by 6 is 3. Literally, I'm thinking in my head, 2 to the 6th is 64. And then 18 divided by 6 is 3. Or, again, if Addison doesn't know what to do, if you'll raise everything to the 1/6 power, 64 raised to the 1/6, type it in your calculator, you'll get 2. 18 divided by 6, you still are going to get 2y plus 1 to the 3rd. No matter which way you're thinking about it, I'm still ending up with the same answers every single time. Okay, I've said enough words. You need to practice this. Clearly, this is something that needs practice. I'm going to give you the answers Monday afternoon. We're going to say that you're going to try on the next page. We're going to give you specific ones to try. Let's say I'm going to take off specific ones. Let's back up. I'm going to take off specific ones. I don't like number 2. I don't like 23. You don't have to do 25, 26. Let's say if you do 27 and 28, let's see, you don't have to do 30 or 33 or 34. In fact, let's say after 34, you don't have to do anymore because that's too many problems. Whew. That is a lot of problems. So Mia needs to do, let's see, it's 1, 3 through 22, 24, and then she has some calculator ones, which are 27 through 29, 31, and 32. So that sounds like a lot of problems, but you literally should be able to fly through them. Heck, number 3 I know is plus or minus 7 to the x squared. You literally should be able to fly through them. I'll give you 18. 12 divided by, that's a 3, is 4, so it's 8 to the 4. A lot of these take literally 2 seconds. So yeah, you got quite a few, but they don't take long. The issue is what number's on the radical. So if you're curious, this is a 3, a 3, a 3, a 3, a 5. This is a 3, a 4. We're going to make that one a 6. A 3, a 6, and a 4, and a 4. They're really hard and tiny to read, and I hope that helps. I will probably take a picture of this and post it on Google Classroom as well, just so you don't forget what numbers, since I've changed it all up. You're going to have all of class on Monday to get this done. But if Hunter didn't hear my words, which clearly he did because he answered questions, if Hunter didn't hear my words, he's not going to be able to do this worksheet, and he's certainly not going to be able to do this on the test, which is going to start on Tuesday. And in fact, while Hunter has all class period on Monday to work on this, he